Good morning and a very warm welcome to everyone present here today. I hope everyone is staying healthy and safe, and I welcome you all to this lecture on reliability, availability, and maintainability for asset management, which will be taken up by our resource person for today, Dr. S. Saravanan of Hottinger, Gruel and Care. I hand over the session now to Mr. Leela Vinodan sir for the welcome address.
Hello everyone. Hope everyone is having a safe stay at home. And I welcome to this guest lecture, which is on reliability, availability, and maintainability. So, in short, we can call it as RAM. So, we all know the importance of RAM in computer and as well as in mobile, right? So, like that, this RAM is going to play an important role in the system and the product. So whatever system you want to design or a product, otherwise if you want to maintain a service, then these are the three important terms which is going to determine the life cycle of that particular service or a product. Okay, so I would like to mention an important thing here that we are all supposed to be safe from the COVID virus, but we have to remember one thing. In terms of computer, the virus is basically the full form of the virus is called as vital information resource under cease, right? So we are supposed to keep away from the COVID virus, and we have to grab as much as information in this particular pandemic period. So I think that's what we are going through. So we are going through a series of guest lectures, and the resource person, those who are delivering the lectures, are giving the valuable information from their experience. I think this will nurture the students to enhance their skills and then to get to know about the details which is currently going in the industry. And I hope that with this, I would like to call Ramuti sir to introduce our resource person, Dr. S. Saravanan. And once again, I will like to thank you all for joining this particular guest lecture, and hope you will have a lot of information in this session. Hope you enjoy it. Thank you.
Thank
Ramuti
you,
sir.
sir. Thank you, Milan. Yes, sir. Yes, sir. Uh, Dear students, I am Ramamurthy, Assistant Professor, Mechanical Engineering Department. I feel glad to conduct this guest lecture on the topic of reliability, availability, and maintainability for asset management. It is a subject related to TQM and reliability engineering, which we studied in this semester. I believe this guest lecture will involve and invoke some insight in the field of reliability engineering and what is presently happening in the industry. At this juncture, I will proud to give introduction about our resource person, Dr. S. Saravanan. Dr. S. Saravanan is graduated in Mechanical Engineering from Bharathidasan University. He received his MTech in Energy Engineering from National Institute of Technology, Trichy. He was awarded with a PhD from Indian Institute of Technology, New Delhi. Dr. S. Saravanan is a certified reliability professional and serves as senior application engineer of HPM Francia. HPM Francia is a statistic segment for layers of and encode. He has been championing and enabling the use of proper reliability practices in India. He has proved consultancy and training services to numerous companies and organizations in India's industry, like Vestas, Applied Materials, Maruti Suzuki India Limited, Mahindra, JCB, TAFE, TMTL, Covident, Royal Enfield, Dr. Reddy's Lab, Reliance Industries Limited, and Defense Research and Development Organization Labs, and Director of Technical Education, Maharashtra State. Here's a reliability growth analysis project of light combat aircraft and warranty analysis of TAFE, TMTL, and JCB. Reliability program of DRDO lab and the reliability prediction of novel submarine system and IMI. Before joining Reliasoft, Dr. S. Saravanan worked as a technology manager in Reliability Center and Condition Monitoring and and Diagnosis Research Center of ZZ Global Compton Grace Global R&D Center. He was involved in condition monitoring and fault diagnosis of power transformers and HT motors and reliability assurance of consumer products. Now I like to invite Dr.S. Saravanan to deliver his guest lecture. I will start the presentation. You can now present.
Yeah, no, thank you very much.
Thank you.
So I didn't know Ramamurthy will read all these things. So if he's reading all these things, I would have given so many things. Okay, thank you very much. Let me share my screen. Are you able to see my screen with slide?
Yes, yes.
Okay. Okay. So in a way, so the subject like a RAM subject. Let us see about that. What's that? So the given time, maybe I need to close by 11:30. Okay. So I try to manage. Okay, no problem. Right. So of course, always in industry, what we feel that the meeting has to start with the ending time. So we stick to the agenda, and time is precious. Time is money. Okay. So such a practice is to be there when when the students comes to industry. So this is what everybody accepts in a way of working with MNC culture in a global companies. Such a way, I stick to the time 11:30. Yes. So in between, if you can have any questions, you can stop me, and we can have some little bit of idea. Please remember, this is a very big subject, and this has no end for that. Okay. So even though I have experience of 20 years plus, so I still learn the things. At least I read 4 to 5 hours daily to solve some customer problems. So such a way, this subject is very vast, and one has to update on a dynamic basis. So what do you mean by dynamic? So what happens on every day? Okay. Let's move that. So you can refer that Relaya Wiki for any kind of equation stuff like that. So maybe students are happy. I will not show you any equations. But please remember, without equations, without mathematics, we cannot solve anything. So everything is governed by mathematics in the world. So such a way, you can refer the textbook style of information from the Relaya Wiki, which is maintained by our company. So the Relaya Wiki seems to be like this. It's a live data analysis, system analysis, reliability group. So it's a big, very big subject. So there are different modules inside into that. So you can refer Relaya Wiki or for your theory references. So with this introduction, our company, who we are. So we are a company with a global presence. Sorry to bother. Can I ask Ramamurthy to mute the mic, please?
Yes, sir.
Yeah, if you want to talk, just unmute and talk, please. Thank you. Okay. So as a global presence, if you can see here, we are all over the world. So I am from India office. So our office is in Chennai. So due to this pandemic situations, we work from home, and we didn't. I think past 1 year I didn't travel to my office. So such a way we do everything in the online and stuff like that with the virtual kind of setup. So what we do? So we promote the reliability culture and the durability culture. So there are two things: reliability. Okay. So we produce softwares. By the way, to make the software, we need mathematics. We need the background of statistics. We need the background of how things are failing. So we do have all the knowledges. Our company will have the resource persons with all the knowledges of the data analysis, how the data comes from, and how to conduct the experiments. So many other stuff like that. So we develop software. You can see the n number of softwares which are developed in our company. So RS indicates the Relaya software, which is totally from the reliability point of view, and the N code is for the durability software. Sometimes, if you see on the road, you may see some camouflaged vehicle. So camouflaged vehicle in the sense, the vehicle with the paint like a forest. So when you go to a forest or military kind of a cloth, okay. So the car is covered by the military kind of a cloth, or car is painted like a military kind of a camouflaged vehicle. So the vehicle are under testing on the road. So what happens? Every company tests the vehicle on the road. What happens if they release the product in the market? So they try to understand how the things are failing in the real situation. Say, in the laboratory, you can conduct experiments, but you cannot simulate all the conditions in the real life in the laboratory, because temperature varying, humidity varying, and vibration is varying on the road. Okay, when your car or you are riding a bike, you will see a rain, and you will see a vibrations. You will see a bump on the road. So many things are happening on that at the simultaneously. That's the reason company needs to see this on the road. So they are called this road load testing. So the ENCODE software is most of the time which deals with the road load testing analysis and convert that information into the how to test in the laboratory with the laboratory profiles. So by the way, reliability and durability go hand in hand. Okay. So most of the structural items what you have in your shipping industries, they are going with the durability testing and connecting with the safety point of view of all the equipments together. Such a way, let us see what is that. Why we need this subject? Why it is interesting? Why it is important? I hope all the shipping industry are eagerly seeing about the one message in the world. Okay. So if I just show you the picture, you can find out the importance of the reliability. So definitely you guys followed this message in the Egyptian Suez Canal. One ship was totally aground. So aground means the ship turned it. So it stopped the entire pathway of the Suez Canal. So it was monitored for mostly 6 to 7 days, and the entire world is hampering because of the shipment. Okay, so the one ship started from China, and it was supposed to reach the Netherlands. So it was in between the canal, and it stopped the entire movement of the shipping industry. So there are many of the automotive companies could not produce the product because of there are some components inside the ship. Okay, some component in the container they are expecting. So the entire world was worried about this. Okay, still the Suez Canal Authority is fighting with the company, those who made the mistake. Okay, so this may be, so still there is no reason is found out. If you see about the root cause, there is no root cause available to the world. So what happens? The situation they are asking for the money of to the amount of $600 million. The ship owner company needs to settle some $600 million. Okay, for this one single incident. Say you may think that this incident might have happened by the high wind situation happened during the Suez Canal, but there may be some mechanical failure also possible in that. So in a shipping kind of a situation, there may be some autopiloting, and there may be a manual way of doing the things. In case of autopiloting, is not performing the way you expect, you can override the autopiloting by the way of manual. So we don't know till now until the failure analysis would reveal the message. But at present, people are expecting there may be some problem in the way of mechanical kind of a failure happened in the system. So that's the reason the ship could not able to control it back for the wind situations and the sandstorm situations. Okay, so this is what the cost of failure, the importance of failure. So everybody is thinking about that. In a company point of view, it makes the loss in the revenue because of this product is unavailable. In a way, the 6 days of the ship which was hampering in the Suez Canal, which makes the entire world to go around, and it hamper the most of the production units. So the reputation when the downtime is public. Now you see that no company can hide their failure because the Facebook, WhatsApp, and Twitter, LinkedIn, you say all the mass media, all the medias are available. In case anything fails, it is immediately in the break news. Okay, such a way, companies are worrying nowadays, and it definitely plays a vital role in the reputation. So I can show you a number of examples. One single failure is sufficient to demolish a company. So that's what happened. If you heard about I think I'm not sure whether you heard about you know about the BlackBerry. The BlackBerry is the mobile company. There was a failure in their server, and after the failure, the company could not pick the business. So this is what happened. One single failure is sufficient to demolish a company. So by the way, the cost of downtime is huge, and the cost of settlement of liability is huge. So this is the reason now every company is fear about this kind of scenarios. So what to do next? They need to see about that, how they can best do the maintenance. Now, if you see the oil prices, so once upon a time, I mean that there are maybe 3 to 4 years back, the oil prices are $150 per barrel, something like that. Now it becomes to $30-40. So you think about the scenario. During those period of time, it was a golden opportunity for the companies to make a lot of revenue. But nowadays, it is neck to neck. We call in business neck to neck. So what you produce and what you earn as a revenue is totally it's a very minimal. Such a way, from a maintenance point of view. So why I insist that most of you as a students, you studied in the maritime industries and you go for most of the time operating the ship or maintaining the ship or doing something in the ship. Okay. Such a way, maybe you may design a ship. So this kind of a maintenance practice, this kind of a reliability practice is very important when you design a product and when you maintain the product in both the places. So sometimes from a designer point of view, it is important. And from a maintenance point of view, this is also important. Okay. So what people expect from the maintenance guys? Say somebody says, hey, I want increase in safety. So I want to forecast the spare parts. I want to optimize that production output and quality of output. Oh, I want to reduce the maintenance cost and reduce the maintenance time. So where the bad actors? That means what is the bad situation happening in the system? So ultimately, as a life cycle cost. So if I buy a product and there are some expenses happens in the way of maintenance, I may call the maintenance person. I may do some spare part changes. So such a way, what would be the life cycle cost of the product when I see this? So this is the life cycle cost is a very important parameter nowadays when you buy an electric vehicle. So if you think about that, you may think about a bike with a petrol, and you may think about a bike with an electric vehicle battery. So initial investment of electric vehicle may be more, but running cost is very less comparing to the petrol. Now you see the petrol is reaching 100 rupees per liter. So how much mileage you can reach? But with the batteries, this is in a rupee. It's a very minimal amount of the money you are spending on the running cost. So such a way, the life cycle cost is a matter of concern in most of the situations. So altogether, from a maintenance point of view, we think about these scenarios. Okay. Let me go into the little bit idea of what is the meaning of reliability. So in a world, we know about this terminology like ability. So if we think about that as an English word, suffix of reliability. So if you can imagine and refer the dictionary, there are more than 390 terminology which are ending with ability. So something like maintainability. Okay. So in classrooms, I used to write it on the board, but it's very tough for me. So maintainability, how easy to do a maintenance? Probability, what is the chance of the failure as a probability, mathematics? Okay. And what is the sustainability? Sustainability. Okay. So these are all the things which are ending with ability as a suffix. Okay. So in total, the reliability engineering subject will take care of all these abilities. So now you can ask a question: how sustainable is my product? What do you mean by that? Sustainable. So sustainable means environmental sustainable. So recently, you may I think just before the pandemic, Indian Parliament announced the BS6 norms for automotive engines. So what is the BS6 norms? The BS6 norms is for the environmental norms. That means the engine should not produce the smoke which are affecting the environment. So this is sustainable. So the automotive industry needs to tune their engines, needs to tune their mufflers, by the way, the exhaust, to reduce the pollutant. Such a way, it talks about the reliability phenomenon. Okay, if they are failing to do that, then they will be penalized. They will be punished. They will be given a penalty to that. Such a way, such kind of a scenario is talking about the reliability. So in total, reliability is covering every aspects of that. So as a formal definition, if you refer any of the books or something like that, in a simple English, this reliability is the probability. So if I'm not reading from the slide, the probability of the particular item, whether it will fail based on the not fulfilling the function, right? So reliability is the mathematical function of probability, and reliability is the mathematical function of a specified time period. So what do you mean by specified time period? So you cannot expect the product live for so much of long, and you cannot think that product will live for long. Say everything comes with a life. If you buy a mobile, maybe it is 1 year for you. If you buy a laptop, it is 3 years. Most of the corporate company change the laptop for the employee 3 years, because after 3 years the laptop performance degrades. Such a way, everything comes in the life with everything in our real life. The product comes with a life. Okay, expiry. That's the meaning. Expiry date. Okay, and under specified conditions. Now the question is, where the equipment is running, where the equipment is working. Say whether your ship is traveling to the Arctic region, whether your ship is traveling to Indonesian region. So something like that is a specific operating conditions. Okay, so these are all the different terminology which are involved in this reliability definition. So once again, I'm repeating, reliability is the probability of failure, probability of success in a way, with the specified time period and intended function. What do you mean by intended function? So if you ask your mobile, what you are expecting from our mobile? So you want a quick message, that is, you want a WhatsApp message, something like that. And you want a Facebook to be updated. And nowadays, it is very crazy to see that mobile phone is not for talking. Mobile phone is for taking pictures. So now, if you think about that, everybody is selling the camera. Okay. So by the way, you expect something in the camera. So this is the reason you see recent advertisements, they are talking about camera features and this many pixels, that many pixels, so many things. So that is the market. So such a way, if you think that intended function of the mobile is shooting a picture or shooting a video, something like that. Such a way, the things are changing. Okay. So one equipment may have multiple functions. There is no problem. But when we talk about one single item, the probability, specified time period, and specific operating conditions, and the intended function is important. Right. So coming to that, as an engineering subject, say reliability, most of the time it is dealt in statistics. Since I said that mathematics is governing our life. So without mathematics, there is no real life. So everything in our life is governed by mathematics. So how this happening in nature? So as a statistics, okay, if you think about that, the mathematics or statistics, this is governed by nature. Okay, so you may hear about honeycomb structures. So the honeycomb, the honeybee construct the honeycomb in an hexagonal shape. If you think about that in your electronics gadget, you will see a honeycomb structure for heat dissipation. Okay, if you think about if you have your old CPU or the desktop computer, you go and see your CPU in the behind, and you will see a honeycomb structure for the heat emission. Okay. So the reason behind that is the honeycomb structure is the optimum structure with the holding of maximum volume in a minimum place, in a minimum location, in a minimum area, such like that. So as a mathematics in a real life, we do see all these things. So such a way we cannot omit math. So in reliability engineering, this is a statistics. Okay, statistics in the sense probability of success, probability of failure. Then the next terminology is the physics. What do you mean by physics? So physics is the failure physics. So if you think about that, I purchased 1 year back the mobile. Now the mobile is not performing the way as it behaved in the 1 year back. Because 1 year back it was very new, brand new. But today it is aged. So 1 year is the age. So aging is the phenomenon. You can see in this way like a wear out. Okay. Maybe if you think in a shipping industry point of view, the product are wearing out. In the ship, there is a corrosion. Corrosion happens for your shipping structures. Why the corrosion is happening? Because the shipping structure is inside the sea, and because of the salty conditions, you may see a corrosions. So corrosion is not a one-day phenomenon. It takes a time. That means it is an aging-based behavior. So corrosion is a behavior in nature. It's a physics of failure. Wear out is the physics of failure. Fracture is the physics of failure. Okay. Crack is the physics of failure. So this is what I mean, physics. Then coming to engineering point of view. So if I connect that, okay, I don't want a crack in my component. I don't want a crack in my shipping structure in 1 year period. I don't want a crack in 5 year period. I don't want a crack in 10 year period. Now there is a message. Say for 1 year period, it may cost you, the component may cost me 10,000 rupees. The crack should not happen for 5 years, cost maybe 50,000 rupees. Such a way, the engineering is the business. Okay. Say, even if you think that I don't want my mobile to fail for 10 years, then you are supposed to pay for 5 lakhs for your mobile. But who will pay? If a company design a mobile for 5 lakhs, who will buy the mobile? That becomes a big question. Such a way, that is the reason. When you buy a mobile, it may not work as the way you expect after one year or 1.5 years. The reason behind that is engineering, the business. Okay. If they fix the price for the mobile for 10,000 rupees, maybe it may not work beyond 1.5 years, depending upon the way of usage. If you are a very polite user, it may come for 2 years. But if you are a very rigorous user, it may not come for more than 6 months or 8 months, something like that. So altogether, reliability subject is the combination of all three disciplines. So this is what the message. Okay. So we cannot omit physics separately, we cannot omit statistics separately, and we cannot omit engineering. So at the end of the day, it is a business, money. So please remember, when you join in a company understand only M language, nothing else. M means money. Okay. If you say, I save this much money to the company, then you will be promoted. Okay. But you need to show that how you are saving. That is very important. Right. So as a purpose of this reliability engineering is to calculate these informations, doing that stuff like that. Okay. So this is the majority of the questions in industry point of view. So what is the expected life of an asset? So I mean that asset here is the pump. The pump is the asset for me. Okay. In this situation, pump is asset. Say in your shipping industry, you have a pump, you have a compressor, you have a transformer, you have a power systems. There are very big machineries that are running in the ships. So such a way, asset means any component, anything which are called as this. This is like asset. So asset is the product, something like that. Okay. So what is the expected life of this pump? If I ask the question, what is the expected life of this pump? So I may expect something like a 10 years. I may expect something like a 5 years, something like that. But what is that exactly? Is there any possibility to find out? So how many failure will I experience for the next 1 month for this pump? For the next 5 years for this pump? How many pump I need to replace that? So these are all the different questions asked by the industries. How much it is going to cost me to maintain this equipment in the situation? How many spare parts do I need to carry out at what cost? Say, sometimes this pump may be replaced as it is. Maybe it is a very small pump. Or maybe there is no possibility to do the repair on the site. So what people used to do, just manage the situation, they replace the entire pump as it is. So now the question is, how many spare parts, how many spare pump I need to have this to carry out my operations? Can we make it most cost effective? This is the very important scenario. Say, everything you can do repair or you can do replace, but at the end of the day, how much money you are spending? Can you make it most cost effective? That's the optimum point of it. Okay. Thinking of that, so to do with all these answers, we need the little bit background of reliability. Okay, let us see this. Say, when I say reliability subject, without showing this bathtub curve, the reliability subject may not be fulfilled. So what is that bathtub curve? So you see, this is like a bathtub. When you see some of the bigger hotels, you will see a bathtub. Okay, something like that. The left portion of that bathtub curve is talking about the early stage of the failure. In the x-axis, it is a life. What do you mean? Life is the life of the product. Okay. And the red color portion is the aging behavior. By the way, if you see here, the life starts from 0, 5 years, 10 years, 20 years, 30 years, 40 years, 50 years, something like that. Keeps on going, keeps on going. It's like. So if you imagine this situation like a human being, say this is early stage of the failure. So what is the meaning? It is infant failures. So child, the just born babies. And this is the younger generation, the youth stage. Okay. And this is the aging behavior. By the way, the senior age. So if we see that human being, there is a high mortality rate for the children, those who are not able to withstand some diseases. Okay, here. This is infant stage of the failure, infant mortality. This is the middle age, by the way, the youth stage, teenage, or maybe the younger stage. So in this situation, the failure is random. What do you mean by random? The youth or the younger generation may not fail by natural way. Okay, they may fail by some other diseases, something like externally induced behaviors. Maybe some accidents, maybe something like what do you call the suicides. Okay, so this kind of a scenario which are induced externally, most of the time the accident or suicide, something like that. When the human being going to the wearing out, the senior age, yeah, of course they may get some disease by the way of natural death, something happens. Okay, so this is what governed by the idealized bathtub curve. So in real life, you may not see a bathtub curve like this for any of the product, but this is ideal in theory. Okay. Such a way, this is called the bathtub curve. So the same phenomena in the y-axis, if you see here, this is called the failure rate. In another way, this is called hazard rate. Okay, something like that, hazard rate. So in your shipping industry, you may think about something which is related to safety. They call it as a hazard rate. Something like that. Now, how we talk about this reliability as well as maintenance? Okay, so because reliability is for the product, and how do you maintain that product is maintenance. So reliability is inbuilt at the time of the design itself. Let's see how we can be connected with that. Okay. So when it comes to that, just to see here a simple example. Say you assume that you have a big engine in the ship, and you have the engine oil. So as a simple scenario like that, in your bike you have engine and you have engine oil. Say whenever you give your bike for your service, the person may ask you, okay, can I change the engine oil? You say that no, I just changed 2 months back only. So why do I change? The service person may say, hey, this engine oil is supposed to destroy. By the way, engine oil is almost failure. So what they do normally, the service guy just dip that with a dipstick and see the condition of the engine oil. So something like that by the way of pressing in the fingers. So the service guy tried to say that there is a chance of failure of this engine oil immediately after the service. So that is the reason this guy is opting for to change the engine. So in a mathematical point of view, if you see that PM in a way, it is called preventive maintenance. Okay, CM means corrective maintenance. Say what happens if you don't the engine oil? Your engine will cease, and the cost of the engine may be $3,000, something like $3,000. So this is in dollars. So the engine oil cost you $20. So can you see here? It's a huge difference between the preventive maintenance and corrective maintenance. So if in a company point of view, if you think that the company has some 10 lakhs car, 10 lakhs engines. So by the way of mathematical idea, if you think that this probability of failure, okay. So all this in the behind there is a mathematics going on. Maybe I'll show you in a few minutes. Okay, this is what the probability which are calculated based on some mathematics. Okay? So if you think that based on this probability, if you change your engine oil by every 1,000 miles, every 1,000 kilometers, based on the probability metric here, every 1,000 hours, this is the probability of 0.000 something. Now you have 10 lakhs car in the fleet from a company point of view. So if you multiply that with 10 lakh, you will see, okay, that is only one car will fail, one engine will fail. So cost of engine oil will be 9,99,000, something like that, multiplied by 20. So you will have this PM like this. But corrective maintenance, if you just leave the car to fail, okay, it will be only one car, okay, only one engine. So if you maintain your engine oil every 1,000 hours, every 1,000 mileage, you will lose so much of money in preventive. Then what to do? Similarly, if you keep on going in the tabular column, every 2,000 mileage, can you change the engine oil? So still the cost of preventive maintenance is too much. Now that becomes the question. Can you say me what is the optimum level of maintenance? Yes. This mathematics give you at what point of time I need to change the engine oil to minimize my operating cost. So this is what the mathematical behind and application in real life. Now you may think that whenever you buy a car or whenever you buy a bike, if you see the manual, I'm not sure nowadays anybody provide the manual to you when you buy the car. So because these are all available in the internet, something like that. Okay. So if you see that every 10,000 mileage, every 10,000 kilometer, they put some table column. Okay, change this oil filter, change this oil, change the seal, change this this component, change that component, something like that. So they come with a list of components to be changed on different intervals. So company did all this kind of a calculation in the behind to find out what should be the optimum level of maintenance. So this place becomes the minimum place, and 3,000 mileage is the optimum maintenance time for the engine oil, something like that. So this is the way we can see message. Okay, so it is a little bit complicated calculation, but I try to show you in a simple way using the software too. Okay. So now the question becomes when to do the preventive maintenance. So that means reliability concept is required for that. Okay, as a reliability mathematics is required for that. Let me show you something with a background of mathematics or statistics. So I mentioned that without mathematics we cannot run the world. Okay, such a way mathematics is divine. So in reality, we see that random variables. What do you mean by that? Variables and constants. So constant in the sense a number, simple number. Okay, constant. Variable means this keeps on varying. X. Maybe in algebra we solve that X. Okay. So in variable there are two types. One is discrete variable and continuous variable. X. So discrete variable. This is yes or no. So that means you switch on the bulb, you switch on your fan. The outcome is fan is rotating, fan is working or not working. So you switch on the light bulb, it is working or not. In the recent past, you might be followed the SpaceX programs. So SpaceX keep on launching the rockets. SpaceX keeps on doing some launching of satellites. Okay, I think they are planning to launch some 40,000 satellites, and they're planning to do a high speed internet to the world. Okay? So now and then they keep on launching the rockets for the satellites. So as a way of launching the rocket, yes or no only possible. That means it reaches the required orbit or not. Okay. Such a way, this is called one shoot product. So discrete variable is yes or no. Continuous variable is number is from 0 to infinity. So such a way, kilometer to fail your tire. If you run your automotive, if you run your bike, at what mileage you got a tire puncture? You can know about that. If you have the data point in the past history, you can find that. At what point you got a brake failure? At what point you got a engine noise? So these are all the kind of information in continuous data. In another way, if you have a pump in your home, if you have a pump in the industry, you can find out what is the time to failure of the pump. Say, depending upon at what time this pump is installed and at what time this pump is failed. So you can find out. This is called the hours to failure for continuous data. Okay, something like that. So in a variable, there are two variables. One is discrete variable and continuous variable. Most of the time, this reliability we talk about is continuous variable. For the continuous variable, we know time to failure, and we can able to do with the probability density function and the cumulative density function. Okay, so I'm not deriving anything here, just I'm showing, and just to give you the flavor of mathematics. Okay. So for the probability density function for the random variables. So I hope this kind of a image, this kind of a picture, you may have seen some game shows. Let me show you one game show. So this kind of image you might have seen. This is a game show in Vijay TV. Next screen. Ramurthy, can you see my screen?
Yes. Now it is not visible.
Ramurthy, can you see my screen? Oh,
yeah, you are present in the screen. Yeah.
Oh, okay. Right. Just to see that, I'm just showing one YouTube video.
Yes, now it is working.
Oh, okay, fine. Right. So if you see about this game show, this was there in the Vijay TV sometime ago. I hope you know about that. See here, this is the probability distribution function. So now what happened in the game show, that the participant throw the ball from here and the ball goes and it drops from the top. Okay. So what is the chance of this ball dropping in these locations? So these are all different bins. If you see about that, the probability density function, this is called a different bins. Okay. So such a way, if you can imagine this situation like this, okay, the probability density function. So this is what happens as a probability density function. So what is the chance of that the failure occurs in between the range of A to B? So this is what the mathematics behind that. So we are not deriving anything. So integration mathematics happens here. So whenever you wanted to do some calculation area under the curve, you need to follow the integration mathematics. Okay. So this is what happens in the probability density function mathematics. Okay. So as a way, cumulative density function. So probability density function is the integration. Cumulative density function is the differentiation of that integration. Okay. So you will see that in such a way, the PDF is the area under the curve, and the CDF is the differentiation of this integration mathematics, and it tries to see the cumulative number. So by the way, 0 to 1. Okay. In some of the reliability engineering handbook, you will find this the distribution function and the distribution phenomenon, area under the curve, all this information here as a try to solve this method. As a finally, so PDF is the integration mathematics and CDF is the differentiation mathematics. Okay. As a different mathematical function, probability of success is reliability, probability of failure is unreliability. So in a probability of happening an event and the probability of not happening an event, additional will be 1 always. That means additional will be 100%. Say, what is the chance of failure? If it is 80%, what is the chance of success? 20%. That means if you know 1, you will convert that into another. Such a, okay. This is reliability plus unreliability becomes 100%. That is 1. Always the area under the curve is 100%. Okay. So as a way, the unreliability function is the time between the 0 to t. Failure rate function. In some of the places it is known as a hazard function. Okay. The failure rate function is something like the ratio between the PDF function as well as reliability function. No need to confuse, no need to worry about that mathematics. So this is failure per hour of operation. The message is like this. Okay. So sometimes it is known as hazard rate. So what do you mean by hazard? In a simple terminology, the hazard is something which makes the human being to do some safety problem. Say you have a mobile phone. Okay. What is the chance of your mobile phone to blast when it is in the charging? What is the chance of your battery of the mobile phone blast? If you think this scenario, this is very, very rare situation. 1 in million or 1 in billion, something like that. So this is called the hazard rate. What is the chance of the laptop catches fire? Oh, so hazard is always connecting with safety situations. Now, if you think about that, in every house, we have the ceiling fan. So what is the chance of the ceiling fan fall, free fall? Free fall in the sense, when the ceiling fan is rotating, when the ceiling fan is running, what is the chance of the ceiling fan fall? So in olden days, ceiling fan used to fall. Okay, olden days, what I mean is maybe the 50, 60 years back. But nowadays, there is no chance of the ceiling fan falls because you have a quarter pin whenever you do installation of the fan. But recently, I saw a ceiling fan fall on some places. The reason is the person who installed the fan forgot to install the quarter pin in the bolt. So what happened when the fan keeps on running, keeps on rotating, the chance of the bolt the nut which removes, okay, the nut becomes looser. The bolt is coming out without the car because the person installed the fan without the quarter pin. So these are the maintenance problems. So such a way, the hazard rate is something similar, connecting with the safety point of view, if you think about that. Okay. Then another function is condition reliability calculation. So this is very, very important for the industry to think about the extended warranty policy and the insurance policy for the human being and the insurance policy for the product as well as. So Conditional calculation. What do you mean by that? Say, if you buy any product, the company will cover for 1 year warranty. But after 1 year, nowadays company also provide the warranty, but there is a third party warranty also possible nowadays. You can purchase in the internet. You can purchase in the websites. So how company decides the premium for the extended warranty is depending upon how the product is performing in the past history. Okay, they have the messages, they have the data in that. So extended warranty policy is decided based on this mathematics as a conditional reliability calculation. Mean life. This is another one metric in reliability. Mean life. What is the average life of the product? And an average, what is the life? This is called mean time to failure. Somebody refer mean time between failure. So both are same meaning. Mean time to failure is for the non-repairable component. Mean time between failure is for the system, repairable system. Say, when you think about that, your car is a repairable system. Your starter motor is not a repairable system. Your starter motor is a replaceable component. But your entire car is a repairable system. So MTBF is applicable for car level. Starter motor is MTTF is applicable for starter motor. This is the message. Okay. Right. Median life. Say maybe in your school days you studied about this median. When there are some data is given, what is the median of the data? What do? You will put the data into ascending order and find out the middle point. If it is a odd number of samples, 1, 2, 3, 4, 5, 6, 7. Okay. Here it is 7 samples. So this side 3 and another side 3. The middle value is 20. When it is the even number of samples, what do? You take the average of the middle 2 and do that. This is called median. So in reliability point of view, this is called median life. So what do you mean by median life? So the component 1 failed in 11 hours, the component failed in 12 hours, the component failed in 20 hours, the component failed in 21 hours. There are different identical components. They failed in this time frame. Such a way the median life is 20 hours. So this is the information from the median life. Okay. There are something as a way, as a summary into that, common metrics used in the industries. So reliability, unreliability, sometimes it is referred as a B10 life. 10% population fails by what time? Mean life, average time to failure, median life, time by 50% expect to fail, something like that, and conditional reliability. So what is the chance of the product to fail after 6 months in life in the field, after 1 year life in the field? So based on this, the company comes with the extended warranty policy calculations. Okay? Because company makes huge money in extended warranty. Okay, such a because you think that you may buy a warranty for your extended warranty for your product. Let me show you that one simple example. If I click that web page, okay. So this is a web page which goes to the extended warranty. So I can choose any kind of product. Let's say I have a gadget. So I have a digital camera, DSLR camera. Okay. So if I say that, how much is the cost of the camera? Okay, if I say some cost, okay, it cost me somewhere 1.2 lakhs. So it tells me the premium for that 1.2 lakhs camera. What is that? Extended warranty. So please remember, the extended warranty is for the warranty completed on manufacturer warranty. So you can cover it for 1 year, you can cover it for 2 years, something like that. So in case of any theft happens, or in case of any malfunctions happens, this kind of a scenario will be covered under this extended. But always extended warranties comes with the star marks. So you need to be very careful about the star mark. Okay. So now the question is how this calculation is happening in the behind. So that is where the reliability subject lies. Okay. So this is the reason we are stressing here the extended warranty policy with a conditional reliability calculation. So if you say to coverage of 1 year, They may have the data of the kind of a camera or the product, and they could able to find what is the chance of this camera fail for additional 1 more year. So by the way, they come to a conclusion of, oh, fixing of premium of 7,000 rupees is giving the money back to the company. So by the way, if 100 people are aiming for the extended warranty policy, only one person may come to the company and claim the money. So remaining 99% money as a premium is in the pocket of the company. Such a way, this is business. Okay. Right. Let us just to show. Let me show you some simple example how the way this calculation happens. Say, previously I mentioned about there is a pump. This is the sump pump used in some mining industries. So, time to failure information of the pump. I know the installation date. I know when the pump is failed. I have the time to failure of the pump. Okay. So I have the readily available message of time to failure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 pumps. The pump, my meaning is the pump is replaced as it is. Pump number 1 failed. The second pump is replaced. Pump number 2 failed. The third pump is replaced. Something like that. So there are so many pumps running in the factory, and I have spare pumps to replace that whenever the pump fails. Okay. So if I see that, if I put this data in that picture, so one pump failed here in 218 hours, another pump failed something in that. Okay, this is number of days. So I can produce a distribution, something like that. How do I produce a distribution? So now what I do, I just open the software. I just open the mathematics, because this can be done in a very easy manner in the mathematics, the mathematics to solve in the tool. So now I'm opening a software called Variable Clusters. This is our software. We develop the software and maintain the software. So most of the industries practice this software. So what I can do here is I just copy and paste this data. I'm not going into the detail of that because this subject is a 6-month subject in MTech program. Okay. So I copy and pasted the data here, and I calculate the data. I can choose the distribution. There are so much of distributions possible. I can choose any kind of a distribution, mathematical distribution, to solve this. So if you see that, this is what it happens in a histogram. We call this as a histogram. Okay. So what histogram is doing, it tries to find out the occurrence. What is the occurrence or fitting that situation? 160 to 240. If you see the data, it tries to find out how many occurrences happened in between the bandwidth. Okay. I can see the bandwidth here from 0 to 80, 80 to 160, 160 to 240, something like that. It tries to find out the bandwidth and produce the distribution here. So if I see the PDF curve, you can see like this, okay, something like that. So you can see the scale is adjusted automatically. So in another way, you can see the probability of failure, called the CDF curve. Previously, the PDF curve. So here you need to find out the area under the curve to find out the reliability value. Okay, if I ask the reliability of 400 hours, I need to find out the area under the curve of this region less than 400 hours, then find out the curve. So it is tedious. What do? As a simple terminology, I can go and pick this curve. What is the chance of failure at 400 hours? Okay, if I match with my cursor in 400 hours, okay, so it is 24% is the chance. The same message I can see here. What is the chance of failure at 400 days of operation? Is 24%. Yeah, it's a straight away the answer. So this kind of information I can get it over here with easy calculations. So I can see that what is the chance of success? By the way, reliability at 400 days is 75% chance. And what is the mean PX life? Say, if I have some 100 pumps, what is the chance of 10 pumps failure? That is 10%. Is 299 days, 10% of pump will fail. So this kind of a message I can see here, and mean life. Hey, can I say an average life of the pump? Hey, it's 518 days. So how the way this helps the company, they can change the pump preventively. Okay, the meaning is before its failure, they can change the pump, replace the pump in a maintenance pump. So this is what quite possible in this kind of scenarios. Okay. Such a kind of information you can provide over here. Now, if I wanted to change, okay, if I wanted to change this kind of a the maintenance point of view, so what kind of message I want? So I said that you can change your engine oil every 1,000 hours. You can change your engine oil every 3,000 hours. You can change your engine oil every 3,000 hours. But what is the optimum time to do a preventive maintenance? See here. So I have analyzed a pump impeller. Okay. In that case, the time to failure information. Okay. So I can find out the optimum replacement time. Okay. So for the purpose, what I do here is I can select what information. Say you see here, the calculation information are inside into that. So in a distribution, we call this as a beta eta. No need to worry about that. So beta is a parameter and eta is another parameter. Beta talks about the life. So if I change the pump, okay, planned replacement cost is $20 and unplanned replacement cost is $500. So planned replacement means every certain period of time I change the pump, it costs $20. And if I change the pump, if I wait the pump to fail and change, it costs me $500. Okay, always corrective maintenance cost is huge because of lost in production or the unplanned maintenance, so many things. Okay, such a way, if I see that, what is the optimum time to do maintenance? You can see here in the right side. Optimum time to do maintenance is 90 days. Okay, this is the place you see here as a 90 days. Okay, can you see here the message? X-axis is in days. Okay, this is the point. If you do maintenance, you will have the most of the life is consumed at the pump and it is almost closing to the end of the life. If you change the pump here, if you change your pump in 40 days, still there is a life in the pump. And if you change the pump here in 70 days, still there is a pump life. And if you change your pump, if you plan to change your pump in 130 days, already the pump might have failed somewhere here. So this kind of information you are getting from here in the preventive maintenance point of view as an optimum preventive maintenance. So these are all the scenarios practiced by the industries. So if you change the cost, the metric will change. Okay, instead of $20, I put $200. It may show you, okay, you can change the pump by 243 days, something like that, because that is the optimum time to do a maintenance. So this mathematics is governed by the cost. Okay. So by saying these situations for a component, okay, in the case pump, what we call as a component. Now let us put it in a bigger picture. Bigger picture way is something like a bigger systems. Okay, if I say here, say as a maintenance person, when you go to the industries, you will see a bigger system like this. This is like a chiller system. Okay, simple example. There is some heat exchangers which happens. You see there are some pumps and there are some compressors and there are some expansion tanks, something like that. Okay, so by the way, you see a system like this, and the data for the system seems to be like this. Now, if you see the pump one is a restore. So the point here is I have the data from the March month. Okay, so this is the time the pump is replaced as a new pump, and the same pump is come for maintenance in the month of August. So if we subtract this, this will be the time between the failure. Okay, now, and this one becomes the time difference between the repair. So idea is this particular motor is taken as a repair, is failed here, and this is restored back. So if you subtract this time frame, this is time to repair. Okay. By the way, previously we talked about the reliability, time to failure information with a distribution. Now we talk about the time to do maintenance is also a distribution. By the way, if you see that, if you ask multiple people, hey, how much time it takes you for changing the engine oil? Somebody say 10 minutes, somebody say 30 minutes, somebody say 40 minutes, something like that. So if you connect the message, you can put as a distribution for this maintenance time. So this is called mean time to repair, MTTR. So by the way, you can have a distribution also in the mean time to repair. So in a reliability and maintenance point of view, you will see time to failure based on the product reliability, component reliability, and you will see time to repair for the maintenance point of view. So both of them are required when we do reliability, availability, and maintainability calculation. Such a way, this is combination of two. Reliability comes with the product, that is life of the product, and maintenance is depending upon the maintenance operations. Either it's a corrective maintenance or preventive maintenance, something like that. And the maintenance is also a matter of how effective the maintenance is. Okay, all things put together, we can do some reliability, availability modeling. Okay, such. Okay, let me go to that. As a system point of view, okay, I just introduced some of the terminology. Reliability block diagram. Okay, so in your shipping industry, okay, the designer of the ship, at the time of the ship is designed, they take each and every subsystem and do this type of block diagrams. This is called the functional block diagram, reliability block diagram. Okay, reliability block diagram. The meaning is this is one component, this is another component, this is another component, something like that. So they try to see that for the system function, is this component is required? For the system function, is this component is required? Is this component required? So how the way they are connected in reliability wise. Okay. So from a reliability point of view, we talk about in success path. From fault tree point of view, this is reverse of that. Fault tree. Fault tree is mostly used in a failure finding idea. So the Suez Canal case, the failure analysis board will use fault tree. What are the events happened for the ship to go aground? Okay. If we think about that scenario, that is called fault tree. Now, the fault tree is tried before the system is designed. That is the idea behind that. Okay. So if you do the if you find out the root cause, that is the postmortem study. Why the ship is turned around. But how to design the ship not to turn around even if a high wind situation? Is there any mechanism to do that? Something like that. Okay, that is in a proactive approach. Okay, right. So as a reliability block diagram is done in the positive success path, and fault tree analysis done in a failure space. Okay, that's the idea. Right. So most of the time, somebody asks RBD, somebody asks fault. But you can combine this. But mathematically, they are same. But as a representation, they are different. Okay. Let us construct RBD. There are combinations like a series configuration. Series, what is meant by series? Two components are there. Okay. I have a component 1, I have a component B. Both are required to have a system success. Series combination. In series combination, reliability of the system is multiply of system 1, system 2, system 3, system 4, something like that. Multiply of subsystem 1, subsystem 2, subsystem 3, something like that is system reliability. Another combination is parallel, simple parallel. What do you mean by simple parallel? So many people use two mobiles. Okay, one mobile is failure, another mobile is there, but simultaneously they use both. I see some people use both the mobiles in both the apps, both the area. Okay. So it's like a parallel situation. So how to run the parallel scenario? So in a component point of view, this parallel is both at a time, everything is working, everything is connected, everything is activated. Okay. Say, in your home, you have an inverter, you have a power supply backup. In case of main supply fails, you have a redundancy supply. Okay. That is UPS. In the case of UPS, UPS is always on. But when in the case of your genset, the genset is not always on. When the power fails, the genset will come up automatically. There is a mechanism inside. When the power supply is back, the genset will stop. Okay, there is a mechanism to stop the genset. So this kind of a redundancy situation we are practicing here in real life. This is called a simple parallel configuration. Okay. So in simple parallel calculation, the mathematics is something like that. Okay. 1 minus reliability of component 1, unreliability. That's 1 minus reliability means unreliability. Unreliability of component 1 multiplied by unreliability of component 1, 2, something like that. Okay. So the calculation behind that is happening using this equation. Sometimes the combination of series and parallel. Okay, this happens. It depends upon the complexity of the equipment. And K out of N combination is something like in the aircraft. So you will see that the combination is like that. So as a K out of N situation. What do you mean by the K out of N? So at any point of time, I want 2 engines to run. At any point of time, I want 1 engine to run for the safe landing, something like that. See, this is where the real situation of problem happens. Okay. So you may think that I think how many of you know about the belly landing? So belly landing is the scenario in the aircraft. Okay. So if you think that situation happened in belly landing, so one aircraft had a belly landing in Mumbai, I think some 1 week back. So this is what happens. I'm sorry. Yeah. Check with that. Okay, let it. So as a belly landing, if you see here, this is a very dangerous landing. Okay. So many times what happened, not many times, it's a very, very rare occasion. The 3 landing gear may not come out. What if the landing gear is not coming out of the situation, out of that, the aircraft lands on the belly. So belly, okay. So the entire aircraft is going for major repair. Sometimes the aircraft, you cannot repair that back. This is what happens as a belly landing. So there are so much of studies happened on that. So this is the reason in the aircraft, you find so many things are redundant. Okay. Because the aircraft is designed with a higher safety situations. The same kind of a scenario you may see in your shipping industries with so much of redundancy into the practice. Okay. So there may be some complex configurations when it comes to the internet or router, or nowadays the communication systems, the storage. Maybe you think about that Google server. They keep server in many locations. They keep all these kind of a networking scenarios using this reliability block diagram and the mathematics like a Ramstead. Okay. So there are so many configurations which are possible in that block diagram approach. Okay. So finally, you will get equations like this when you wanted to study further. Okay. So I'm not going into that deep of that. Okay. Let me show you one final example with a reliability block diagram. Okay. So how this RAM study happens as an entire scenario with a reliability block diagram. So I just to show you one single pump to demonstrate how this reliability metric and availability metric play a vital role in that. So let's say I have a pump. So if you see here, I can pull a block and I can consider that as a pump. So this is what I did that. I can add a block here, okay? So this is, let's say this is my pump. So I have given inside the value of that reliability. If you can see here, the reliability model. What is the meaning? Model means mathematical model. Okay. So this follows a variable distribution with the beta data, and there is a corrective maintenance. Okay. Let me show you now without that corrective. Okay. Now what happens? I have a pump here. Okay. So if I want to run this pump for, let's say, 5 years, so how many failures do I experience? Okay. If I put 5 years. Okay. So in that case, the pump is not failing for 5 years of time frame. Okay. There is no problem with that. Let me put some 10 years, something, because what is the mathematical model I give is depending upon that. Just a minute. Let me, because I have put some corrective maintenance also. Let me remove that corrective maintenance and show. So in the case, I just run the pump. Can you see here? The pump availability is 8. What does it mean? Say, I have a pump which I'm running for 5 years. Can you see here? This is the pump. It keeps on running, keeps on running. At the end of, let's say it's 1037. Okay, 10,372 hours, the pump is failed. But nobody come for repair of the pump. Okay, so that is the reason the reliability of the pump becomes directly the availability of the pump. Now, if I want my pump to be available, what I need to do, I need to give the maintenance policy. Okay. Hey, in case if my pump fails, what should I do? I correct the pump. By the way, I do some maintenance on the pump to make it back, make it repair. And what is the time to do the repair? So I have some time duration of 75 hours to do the repair. So now you can see here, if I run the pump for 10 years, I will see it is available 99%. What does it mean? For the given time of 10 years, okay, with a percentage of 99%, it is available for the time. This is called availability metric, available time. So my maintenance practice makes the pump to be available for some time. Now, if you think about the redundancy, okay, say, I don't want this percentage of availability. Okay, what is that availability right now? It's 99%. But sometimes what happens, I want 99.999959 or 69s. So for the study purpose, if I have 2 pumps, this is called a redundancy. Okay, just put that. These 2 blocks are called the dummy blocks in mathematics. So that means these 2 blocks cannot fail. So I have not set any reliability number inside into that. So if I have 2 pumps inside in my situation, any one pump fails, other pump will take care. So that means both the pumps are running at the same time. Okay. So if I see here, so it becomes, previously it was 99.09 or something. Now it becomes 99.9998. So if I want 99.49 or 59, then I can keep on adding so many pumps into that. But please remember the cost. At what cost you are doing, that is very important. So if you think that it is a very safety situation, the situation is very much required for the safety point of view, you need to think about this availability. Say, that is the reason in power plant, the power boiler feed water pump, they may have 6 feed water pump. In the nuclear industries, they may have several pumps together, all together at the same time. So if you want to improve your availability, you need to think about your reliability of the pump. Many times, it is very tough to improve the reliability because reliability comes with the design. So such a situation, people tries to think about the maintainability to improve the availability. Such a way, as a RAM study, as a RAM, if reliability and availability plays a vital role. So how best you do maintenance, that is very important. Okay, so that's the reason there is optimum time frame, and there is a maintenance plan, and there is a standby scenarios. Either it's a parallel standby or it is a standby container, something like that. We can play around these kind of scenarios. Such a way, as a whole, this entire reliability availability matrix comes with the money point of view. So when it comes to the industry point of view, so it needs to justify with the money. At what cost we are doing this? So this is very. So with this, I conclude. I think I hope took 1 minute beyond that. Thank you very much. In case if you have questions, you can unmute your mic and ask, please.
Thank you, sir. Students, if you have any doubts, you can ask. No
No
questions?
questions. All clear.
Sir, you have shared practical examples as well as tells about the importance of reliability in every product. You also told how it works in determining the overall life cycle cost of any product. I certainly assure that this lecture will be very much useful to the students in their academics and improvements in knowledge gathering of reliability engineering. Thank you, sir. I would like to call Mr. Milan Maganto to deliver his vote of thanks. Milan?
Yes, sir. Sir, am I audible?
Please. Yes, yes, yes.
I thank Dr.S. Saravanan, who spared time from his busy schedule to grace this occasion and to share his wonderful and inspiring thoughts with us. I hope we can all take note and motivate ourselves and those around us to push that much harder in the field of reliability wherever we go. He has championed the ability and has mentored and monitored the use of proper reliability structures in various organizations and companies throughout India. Thank you, sir. I thank our HOD, the faculties and students for gracing the session and sharing with us your opinions. I thank Mr. Ramamurthy sir for coordinating and successfully conducting such an inspiring session and bringing to the stage the importance of reliability and maintainability in management. I thank the coordinators and everyone else involved in making sure we have a smooth and well conducted. Thank you, sir.
Okay, Milan, thank you. I will share the feedback link in the uh, WhatsApp group and also in the Google Meet.
For regular training program. So there is no need of.
I will.
You can take
Okay,
your
okay.
feedback by your own way. No.
Okay, thank you, thank you.
Thank you, sir. Thank you, sir.
Thank you, Saravanan. Sir. Sir.